Hey everyone! Alright, today's video is going to be over compound probability. So last video we talked about independent events, but this time we are going to calculate the probability of compound dependent events. So a dependent event is when the outcome of one event does affect the outcome of the second event. So the second event is dependent on whatever happens during the first event. The key phrase that you want to look for is that there is not replacement. For example, if you are drawing marbles out of a bag, let's say you draw the first marble and you do not replace it. You have now changed the number of marbles that are in that bag, so it's going to affect whatever happens next. With dependent events, we're still finding the probability of each action, and we are just multiplying them together. We just have to keep in mind that whatever happens after the first event is going to be affected. Alright, so let's do an example together. Example 1, there are 2 red hats and 1 black hat in a bag. You draw out one hat, then another without putting the first hat back. What is the probability that both hats are red, and how likely is it? Alright, so first of all, we've got a picture to represent this situation. Drawing pictures really helps with dependent probability, so if you ever get a problem without a picture, go ahead and just draw whatever it is talking about. So it says that you're drawing hats without putting the first hat back. That lets us know this is dependent. I want to know the probability that both hats are red. So I'm going to write that down. So we've got 2 events happening. We're going to try to draw a red hat and then draw another red hat. Alright, so if we're to draw a red hat, we can see that there are 2 red hats out of 3 total. So the probability would be 2/3. Now, in dependent probability, we assume that we drawed whatever we were trying to get during the first event. So let's say that we did draw the red hat. We drew the red hat and we did not replace it. Now that's going to affect what happens next. Now there are 2 hats and one of them is red, so there's a 1/2 chance of drawing a red hat. And now I'm going to multiply those together. Multiply numerators and multiply denominators. So we get 2/6, and that can be reduced to 1/3. Now, since this is less than half, it is unlikely that we would be able to draw 2 hats, or 2 red hats in a row. Alright, example 2. There are 10 marbles in a bag. 3 are blue, 6 are green, and 1 is pink. If a marble is drawn and not replaced, what is the probability of drawing a blue marble, then a green marble? Alright, so it says that it is drawn and not replaced. So this is dependent. We want the probability of drawing blue, then green. So I'm going to write down what we're trying to find. So we want blue, then we want to draw a green marble. So we have 2 actions taking place. We have to find 2 probabilities. If we were to draw a blue marble, there are 3 blue marbles out of 10. So we have a 3/10 chance of drawing that. Now we're going to assume that we actually did draw a blue marble, and we're not going to replace it. So now that has affected the total amount of marbles. So for green, we now have 6 green marbles, but there are now only 9 marbles total. And now we're just going to multiply that together. Now, I prefer to reduce fractions before I multiply. So 3/10 cannot be reduced, but 6/9 can, and that would reduce to 2/3. Alright, 3 times 2 is 6. 10 times 3 is 30. We get 6/30, and that can be reduced, and we can divide by 6 and get 1/5. 1/5 is less than 1/2, so this is an unlikely event. Alright, example 3. A box contains 3 blue marbles, 4 red marbles, and 2 white marbles. You draw 3 marbles without returning them to the bag. So we want the probability that we draw a red, then a white, then a blue. Okay, so let's write down what we're looking for. So we want red, white, then blue. we have 3 actions taking place. So we are going to find 3 probabilities and multiply them together. All right, so we'll start with red. So there are 4 red marbles out of 1, 2, 3, 4, 5, 6, 7, 8, 9 total. So you have a 4 out of 9 chance of drawing a red. Now let's say we actually do draw a red marble. We don't replace it. Now let's figure out the chance of getting a white marble. So now there are 2 white marbles out of 8 marbles that are left. And now we're going to assume that we drew that white marble and we're not going to replace it. Now let's find the probability of drawing a blue marble. So there are 3 blue marbles out of 7 marbles that are left. Alright. So I'm going to reduce, so 4 over 9 cannot be reduced. 2 over 8 can be reduced to 1/4. And 3 over 7 cannot be reduced. You do not have to reduce before you multiply. That's just something I prefer to do. So you can just go ahead and multiply it as is. You'll just have more to reduce in the end. So now we're going to multiply the numerators. So 4 times 1 is 4, and 4 times 3 is 12. Okay. Now we have 9 times 4 on the bottom. That is 36. And then 36 times 7 would be 252. All right, 252 can actually be divided by 12. So if we were to reduce this, 12 divided by 12 is 1, and 252 divided by 12 is 21. So there is a 1 in 21 chance that this could happen. That is definitely way less than half, so this is unlikely to happen. Okay, now it is time for you to try, so make sure that you answer your question on Educanon and show all your work in your notes. Bring your notes with you to class and have a good day.